Hello and welcome to my tutorial video. Today I'll be explaining how to calculate concentration. Now in solution chemistry, whenever any solute and solvent mix, a solution is formed. Now if we typically look at a solution, in the diagram I have drawn the solid particles which are said to be solute with red and the solvent particles which is usually the liquid particles. Most of the time the liquid particles are water particles. Anything that dissolves into the liquid is called the solute. It could either be a solid, it could be a liquid too, and finally it could be gas. So anything that dissolves in water is supposed to be called as a solute. Now when the solute and solvent mix in a certain ratio, a solution is formed. Many of the times when a certain amount of volume is taken for the solvent, it is known how much of volume is taken. And when expressing the units for measurement of solute of any kind, whether it be solid, liquid or gas, usually the mass of the solute is taken. Now concentration conventionally in chemistry means the amount. When I say amount always refers to the number of moles, designated as smaller n symbol. So concentration is the amount of solute dissolved in a definite volume of the solvent. So if we use the formula for concentration, which reads as number of moles divided by the volume, a few things to keep in mind. The number of moles is usually calculated with another formula which states number of moles is equal to mass divided by the molar mass. And the volume of the solution always has to be converted to liters. So the formula we finally derive is concentration is equal to the number of moles divided by the volume. So C is equal to N over V. Now this straight formula can be manipulated and we can get another two formulas out of it. Since there are three variables, three formulas could be manipulated from this main formula. So at the moment the subject of the formula is concentration is equal to number of moles divided by the volume. So C is equal to N over V. If I wanted to make moles the subject of the formula, to get it one side I'll have to move V on the other side and put it on the top. So number of moles would be concentration times volume. The third variation of the formula, if I wanted to make the volume of the subject of the formula, we will just have to switch the positions with concentration and volume. Volume would come up and concentration would go down. So volume is the number of moles divided by concentration. Let's look at one practical example where we can calculate concentration. Now typically soda contains a lot of carbon dioxide in it. So the reason why carbon dioxide is added to any soft drink or any soda is to make it taste much more crispier and fresh. So typically any can which is of 12 ounce contains somewhere around 0.71 grams of carbon dioxide dissolved in it. So to calculate the concentration of carbon dioxide in this can of soda of 12 ounce, some of the things that we know that the mass dissolved is 0.71 grams. Straight away, when I get the mass of carbon dioxide, I can calculate its number of moles. We'll go on to that formula next. And then volume, it is written 12 ounce, converting 12 ounce into milliliters, it's 355 milliliters. Again, going back to the equation, we need the volume to be in liters, it has to be converted. So 350 converted, milliliters converted to a liter is basically dividing it by 1,000. 1,000 moving the decimal point to the left 3 times, 1, 2, 3, I end up with 0.355 liters. Now the question was to calculate concentration, but before we calculated concentration, it's very important that we know the number of moles. If the number of moles is given in the question, you don't have to carry out these steps to calculate the number of moles. But if the number of moles is not given in the question, it is very important to go one step beyond before calculating the concentration to calculate the number of moles. So the number of moles of carbon dioxide dissolved in 0.71 grams is the mass divided by the molar mass of the compound, carbon dioxide. So the mass is usually given in the question. We don't have to calculate it. It is given in the question. Molar mass for carbon dioxide is what we have to calculate. So the molar mass for carbon dioxide is carbon, one atom of carbon, and we add the atomic value for 2 atoms of oxygen. So carbon, the atomic value according to the periodic table is 12. And oxygen is 16, so 2 by 16 gives me 32. Carbon is 16. Carbon is 12 and oxygen is 16 by 2. So we end up with a 32 plus a 12 which gives us 44 grams per mole. So Substituting the values in the formula, MR I am putting as a 44 grams per mole at the denominator position. So 0.71 divided by 44. So it's 0.71 divided by 44. We come up with a very long value. It's 0.016136. It keeps on repeating, keeps on going. So I will use 0.0161 at the moment. So the question was specifically asking us to calculate concentration. So we'll go back to the three variations of the formula and see which formula we could use. The subject of the formula to calculate concentration is the first one, which is the number of moles divided by volume. The reason why I calculated the number of moles, it was not given the question, but volume was given. So we are going to use the first equation. Concentration is equal to number of moles divided by the volume we are going to take. So the number of moles we just calculated as 0.161. So using my calculator, I'm going to use the same value given, because I'm not going to convert the answer somewhere in the middle of the calculation. So I will simply divide whatever answer I got with the volume that I'm supposed to use as 0.3555 divided by 0.355. I get 0.045. So the final answer is 0.045, and it's a long value. We don't have to worry about writing all of them. So conventionally, whenever a final answer is given, it has to be converted or rounded off to 2 decimal points. When I say 2 decimal points, that is the decimal point, and 1, 2, we move one more up, that is 5. We're going to look at 5, the third value after the decimal point. If it happens to be 5 or greater than 5, I could take it off, convert this number, and add a 1 on the top of the number before it. So that was a 4. So the new number will now look as 0.04 plus 1 is 5, 0.05 mole per liter. Now, to summarize, it is very important for us to convert whatever volume given to us in volume as volume in liters, and if the question is not giving us the number of moles, we have to use this formula. Number of moles is equal to mass divided by the monomass to calculate the number of moles.